Hi there. Let's prove the Tan Chord Theorem. So this is an exam question, and we are told that in this diagram there are chords AB, BC, and AC with a center at O, and DCE is the tangent to this circle. They then asked us to prove the theorem which states that the angle between the tangent to a circle and the chord drawn from the point of contact is equal to the angle in the alternate segment. Thus, we have to prove that BCE, which is over here, is equal to angle A, which is right over there. Okay, so let us begin. So we're going to start with a construction. So we're going to draw a radius from point O down to point C, and then another radius from point O up to point B, like that. So let's write that. Construction, draw radii OC and OB. Nice. All right, so because we're looking at angle BCE being equal to A, we're going to have to start with the angle at the tangent, which is BCE. So at BCE, we also see that there is that radius OC that touches our tangent. So that's very helpful because we then know that OCE will be equal to 90 degrees. Why? Because a tangent is always perpendicular to a radius. So if that tangent is perpendicular to a radius, creating angle OCE, that means that we want to look at BCE. Therefore, it will be equal to 90 degrees minus the other angle. So let me highlight it in a different color. This small angle, which is OCB. And we can say that is because they are complementary angles. They add up to 90 degrees. I'm thinking of supplementary angles, which add up to 180. All right, so now that we have BCE in terms of 90 degrees and OCB, we then shift to looking at the triangle OCB, right? So we know that OCB will be equal to the angle at OBC, and our reason is that these angles are opposite equal sides. So angles opposite equal sides. So if they're opposite equal sides, it means that here we have an isosceles triangle. Therefore, these angles are equal. So because we have an isosceles triangle, to get that angle at O, so we can call that COB. It will be equal to 180 degrees minus twice the size of OCB. And we want to use OCB because that's the angle that is close to BCE, our focal point. So, and the reason for this is because of sum of angles in a triangle, they add up to 180 degrees. All right, so now that we have COB, which is over here, we can therefore get the value of angle A. So angle A will be half the size of angle COB because of the angle at center. So angle A will be equal to half COB, which is equals to 90 degrees minus OCB, because angle at center is 2 times angle at the circumference. So because of this, we now have angle A. But look at that. Angle A is here. Let's pick a different color. So angle A is that. Let's make it wider. So this is angle A, but it's also exactly the same as angle BCE. So therefore, we can now conclude that BCE is equal to the angle at A. And thus, we have proved the Tan Chord theorem.